Oh wait. Oh, I forgot. Hold on. My camera is not set up. Let's see if that does it. It does. It does. It does. Can I not be stretched? I don't want to be stretched anymore. Hooray, I'm in my correct aspect ratio. All right. Well, well, well. Yo, what up? Hi. Oh, wait. Hold on. There we go. Hi, I'm SolarLune. I'm an independent game developer. I'm the creator of Master Plan. I'm the creator of Tetra 3D. Uh, yeah, I do stuff. I'm doing stuff. Watch as I do stuff. So yeah, hi. For the past couple months, I've been working on this game. This is a 3D actually game written in Go. It's kind of becoming this weird kind of thing, but it's kind of shaping up too. Um, it's kind of like a walk and talk adventure game, something like Yume Nikki or Ib or games like that, where basically you control a character and you walk around and talk to people and solve puzzles, um, that kind of thing. It's going to be pretty small, and this is what I have so far. Oh, I paused. There we go. This is what I have so far. A player walking around. You can talk to people. Yeah. There's an inventory system, but I have yet to re-implement it basically because I've been making some changes. But yeah, this 3D game is using my own 3D renderer, Tetra 3D, written in Go using Ebitingen. So it's basically drawing triangles and rendering a depth texture and stuff completely without a 3D API. So I'm transforming the triangles. I'm doing depth testing using a shader, all that stuff. It's not the most performant thing, but it's not bad. In this case, I'm getting 1 millisecond, 2 milliseconds of render frame time with this little simple PS1 style scene, which is pretty good in my opinion. That's actually really good for a homebrew 3D engine. I think this should run fairly well. Putting it on, for example, put it on the Steam Deck, and I'm getting like 4 hours or 6 hours of battery life, something like that, which is pretty good. Not bad. I have to retest it to see, but yeah, I'm satisfied with the render, speed, all that stuff is going really well. Physics could be a little better, but it's not bad. It definitely works. It's just a little janky. You can see the character kind of slides a little bit, like right there. So there's some things I need to work on, but overall, it's pretty good. I'm pretty happy with this. Yeah. So between the last stream and this one, I moved from Goja for my scripting language to Yaigi. So what that means is instead of using JavaScript for my scripting language, I'm using Go for my scripting language. And the upside of that is, of course, um, for one thing, you can use Go instead of JavaScript, which is, in my opinion, it's a little bit better. It's a little bit more, well, it's a little bit simpler, as well as a little bit more maybe literal, which is good, I think, for video games. Rather than being, kind of dynamic, you can just be like, to be able to have compile time, um, compile time like linting and examination of your code is of course very nice. To be able to have good not syntax support, what's it called? Where you have in your like auto completion and stuff like that, so you can see like what functions are available or what um fields are available. You kind of can you can see if you like misspell something or something like that. So that's very nice. Another thing that's very nice is that it runs faster than Goja. I'm not sure if it's just, yeah, I'm not sure how necessarily, because I feel like I've seen benchmarks that said Yaigi was slower than Goja, but I think because at least the way I'm using it, I'm doing a lot of like Go interoperability stuff, so maybe that's why Yagi runs significantly faster, maybe twice as fast, or so. So we'll see. So like for example, here is and this isn't going to be exactly correct, but let me see here if I can. Oh, that's why. Okay. Let me see if I can get this to be what I need it to be. This is small image game. Get to that. Let's see here. Okay, so we'll see if this works as I would like it to. And we'll see how accurate it is. Oh, it won't work because this is old. Okay, we'll have to change that. Let me do some stuff here. So this is basically like the JavaScript backup I made of the game before moving to Yaigi, where I was using Goja. Just need to make some tweaks here, so we're gonna do that real quick to see if we can get it to work. So that's interop, main, and scene. Okay, so search tree by parent bytes now by lop. I guess we'll just do it like this for now. And then yeah, something like this. Excuse me, and then over here, search tree by regex. It's not just by name. And then this is by prop name regex. It's not by prop regex. Cool. Something like that. So we'll see if this works. Okay, it works. Oh, but it doesn't take me where I want to go. Okay, that's fine. It still runs. Yeah. This should be JavaScript, right? Yeah. Well, maybe it's not that much faster. But in any case, this is like 1 to 2 milliseconds here with JavaScript with Goja. Sometimes it goes up to 2. Okay. And then this is with Go. It's about the same, I guess. Maybe a little slower, going up to 2 sometimes, periodically. Yeah, but so it's about the same in terms of overall logic execution. I feel like it should be faster because I'm using Go interoperability so much. And I feel like most games would, so that it's like, it's going to be faster. I feel like because the types don't have to be, uh, really like transformed between JavaScript and Go. It's just Go and Go, right? Like if it's a struct in Go, it's a struct. Like if it executes a script to define a struct in Go, then the struct is defined in Go. It doesn't need to like transform it between 2 different types for JavaScript Go interoperability. It can just be in Go. So I feel like it should be faster to work with Go with Yagi than Goja, but if not, that's fine. I think I still would probably prefer Go because it just has better auto completion. It's a more it's kind of a simpler language. More defined, I feel like, and also it should be that you can import scripts and things nice and easily with Yaigi, where basically it just is about putting things in this source directory, or me extracting the sources of things that are useful, like in this case my Asprite importer and loader, Tetra 3D, Ebiton, all that stuff I can like export or extract those symbols. I can extract those and put them into kind of bake them into the game so that when people, if a script tries to import it, it works. So it's an interesting change. I feel like I prefer this. Again, it just feels a little more defined, I think. And I like definition. I like simplicity and I like definition in my code. So let's get some music going and then we'll get working on this. Let me make sure it's not too loud. It probably is, actually. Nice try, brain, but I am on to your tricks. Yeah, right around there. Okay, so so the way that this works is a little interesting. There we go. We'll do it like that. Do that. The way this works is a little interesting. Basically, a script in my game, which, for example, the player is a script. It is in a folder in the assets directory. It's just called player.go. It matches the name of the script defined in Blender. And I also made my own Blender add-on that basically allows me to set those kinds of properties. So, or set properties like that, like in the assets I export. So I define the player and I say, oh, he should be using the player script. And then basically it just has, I define a type in the file of the same name with the type of the same name as the property in Blender. And then this defines like, okay, this is the thing that gets instantiated and put onto the node, onto the object in game. And so there's an interop library that basically has some helpful functions that are just stubs here, but they are defined and overwritten elsewhere. They're defined here so that I can have some code completion, so I can know like, oh, this is what these properties take and this is what they do and all that stuff. But I don't actually have to have this written here to use these functions because they're being provided from the script, from the interpreter internally. So yeah, I can say like, okay, well, let's get the node. Let's load a resource like an ASE file, a sprite file. I can read properties on the scene or read properties on a node, for example. So it's very good in my opinion. It's a solid solution. It's a solid solution in my opinion. And so it's an interesting thing because if we go to npc.go, this is basically like a NPC, that can walk around and talk to people and stuff like that. And this is what defines like what the routine for an NPC like that is, where he's, if he's idling, then he walks around randomly. If he is interacting, then he locks the game and then says some sort of message and then unlocks the game and changes his state, for example. So what I'm thinking, and this is kind of an interesting thing because in JavaScript, what you could do is you could call a function with the provision of self from another object. So rather than calling the function with self being defined as the caller of the function, or like basically you could provide self to JavaScript. I guess I can show it like this. So if I say like actions.setFacing, if the target object is not defined, then I can use this and this. That is how I was doing it. I don't like... Well, okay, so there's a couple of things about this. One is, I don't know how I feel about this kind of... There's a couple things. One is, I don't know how I feel about kind of like magic code, like this, where I say, this is JavaScript, where I say set movement, actions that's dot set movement. This creates an action that when executed would set the movement of the NPC. So it sets it to nothing basically, because I'm not passing anything into the function. This is a little magic because I'm never actually stating where, like what object this action operates on, and I'm never actually passing the movement variable, but it's very consistent. I mean, it's very easy to read and easy to type. You could do that kind of thing and go a couple of different ways. One is like this, where basically if we have a function that operates on an object, we pass a pointer to the relevant variable. So for example, I say, okay, I want to randomly move this NPC around this area. He should move at 0.02 units per frame, and his home location is home POS, home pause or position, and that's basically the location he's at when he starts the game. And I can provide a pointer to the movement field, this guy, so that it says, okay, well, whatever movement we calculate here, we're gonna put it into the out variable, into the pointer. That works. We can do that. Another way would be to make it so that this function takes an interface of something that can provide a movement, an interface for something that can provide a function that sets movement. So for example, we could do this. We could say, okay, well, let's define an interface. Oops, type movable interface. Say set movement vector 3. So we could do something like this, and then we would define on our NPC a function that sets the movement variable, which is fine. We could do that, right? And then we basically take a movable argument, call move like this, mov movable, and then we just call mov.setMovement, and then there you go. So this also would work, where basically rather than setting the variable, the field directly, we can take an interface and we can provide the NPC. We can basically make a function to set the movement manually, but that's a little wordy. Both of these are a little wordy. So we can just basically like do this the most magic way, which is how I was doing it in JavaScript, where essentially we're just setting the script field like dynamically with no real like rhyme or reason kind of, or we can just say, for example, we don't have an out variable, we don't have an interface that we're calling functions on, we can just literally call this, where we say, okay, we're gonna call on well, we would still need the target. Well, I guess we could just say interrupt node and then movement, and then set it to we could do something like that. So that's an idea. The upside of this is that it's very simple. Yeah, it works. The downside of it is that well, there's a couple of downsides to this kind of an approach. One is we can't specify optional arguments unless we like made a struct for this, in which case it's like, why even make a function if you also need to make a struct? Why not just make a struct and make this a method? So if that's the case, then this would be an interface that basically has a boolean, a function that basically indicates whether the action takes effect or not, or when the action takes effect. Which means that we also need some method to reset the action, because before I'm using closures to make this happen. For example, here, this wait function is using a closure. It's basically defining a variable that exists outside of a function. The function iterates on the variable or changes the variable, and so this creates basically a memory. This creates a memory for the function, It's essentially like a struct, right? Because we're defining fields here. Well, we're defining a field here and here, and then the function reads that. It modifies those fields and reads that, and that's essentially a struct. It's essentially some location in memory that kind of controls this stuff. So we can do things a little bit differently. What I'm thinking is basically, I like things to be simple, which means I especially for this, where you're like, normally when you are writing code, if I was writing code for most things, I think it would be fine to be verbose. But because NPC routines and things are so like wordy, like you're gonna be typing this out a lot, of like them saying things, them setting variables, them moving, them locking the game, unlocking the game, sending messages, switching states. Like that's such a long series of things that you want it to be as wordless as possible, right? Whereas like if you're setting the movement, for example, the movement of an NPC, like it shouldn't be magic, so to speak. It should be explicit, but all NPCs are gonna basically have the same movement field, and they're all gonna be working the same way, essentially. So it's like, okay, well, we don't need to be overly dogmatic about this, right? Like we can have some syntactic sugar and things like that, just not because it's ideal, but because it's ideal for the workflow. So that's probably what I'm going to do, is just switch things around like this. I'm going to make this an interface, make it a poll. I'm going to make it so that not every action needs to have this function in it, but if it does have that function, then it can be initialized or reset. I guess that might be a better term, resettable action. So now this becomes a struct, and then this becomes a poll. Now this becomes our fields, right? Speed, home, and the target, which is an inode. Which if it's nothing, then we can just substitute essentially the calling object, right? But the reason why I'm doing this is because you may want, for example, to set the movement of a different character or a different unit or entity to move to a different location. So for example, the player, you might want to move him somewhere else, in which case you would set the target to be the player rather than leaving it blank or setting it to the calling NPC. In which case we probably need to use this. So yeah, this is, I think, probably for the best. I'm thinking. Let's see. There we go. So that's the idea. And this is also something that you cannot do in, well, not you can't do in Go. You definitely can do it in Go. It's just most people probably wouldn't do it this way, but this allows you to just set a field by name directly, which is useful. I guess the alternative is to use an interface, which that can work. There's nothing wrong with that. Yeah, I mean, no, I guess this is good because I'm thinking there's a couple of different ways. There's a few different ways to like interface with objects with other structs in Go. One is to use an interface, right? And then the struct provides the interface. It provides functions that fulfills the interface. That's one way to do it. That can work, but the problem with that approach in this scripting system is that each script is an object inside of a script, right? Inside of a Golang struct. So it's a little difficult to retrieve that object to determine if it to like really get the object, the backing object, because in our scripting system it doesn't understand the external scripting system, right? Like in our scripts we have like the camera, we have the player, we have NPCs, but they don't understand like you live in a script and what that means. So for us to be able to retrieve it is a little bit complex. Well, it's not super complex, but it's not super simple because it's like, well, we can get, for example, the node and then get the script that's operating on it, but there's no definition of a script in our script, right? There's no concept of a script inside of here because the concept doesn't exist. So it's like normally you would use interfaces, but you don't have to. You can use messages. Messages are something like interfaces because basically you define what the message is and then you define the response on the message, right? So that's an idea. Let's see. Interrupt that set script. But this is setting the field directly is not good, but it does work. Yeah, this isn't good, but it does work. Messages can kind of be used as function calls, like interfaces. I mean, maybe I could make it so that you can get the object within. Where basically you would do something like this. Where you say if we were given a node.data.script.self interface. So you can do something like this and it would be basically any. So then this should be the object that lives in the scripting layer. That kind of works. It's not perfect, but it does work. But for now, I'm going to say this is fine the way it is. I think that this is a little bit dynamic enough. I mean, because the alternative is to define like set movement or something like that, and then define that function. Which, I mean, we could do that. There's no issues there. But it's dynamic. I mean, I guess we could do that, right? Dynamic, huh? Let's see. Do we want to set? I mean, really, you shouldn't directly set fields externally, probably anyway. I'm just thinking of like a cinematic where, or actually in the old version that was using JavaScript, there was a little, not really a cutscene, but just a little interaction when you go into this void room upstairs here, where you go to like interact with the door, and the guy standing there. Oh, I can't go there. Yeah, okay. There's something not working right. You go into this door or you go to interact with the door, and the guy standing there talks to you, and he turns to face you, and you turn to face him. Your character turns to face him. So I don't want to have to make like a set this, set that for everything. Especially considering I won't be able to get, what's the word? I won't be able to get like Okay, let's do it the go way. Let's do it the go way to the best of our ability. So this is gonna look like this. We are going to make that function to retrieve script data. We're gonna put it here. That. So something like this. Oops. So something like that. So then I guess we could say this is a movable. No, I guess we don't want it to be movable. It still needs to be an inode. Because what I'm thinking is it would be nice to be able to like have some compile time assurance that like things should work. So for example, if I have a function that says actions.setFacing, I should be able to provide a pointer to the player and be like, yes, this should work because it's the player. Well, if we have access to what's the word, to like reflect and stuff like that, if we're doing stuff with that, let's do stuff with that. Like, why not, right? So this should be fine. This will be fine. Let's see. All right. Okay, so that's fine. Well, if we say we want it to be after 3 seconds or 1 second, I mean, a floating point is not enough. Yeah. Okay. All right. So this move randomly around area. We got a target, and then it just is gonna set the movement field. Wait. We got to reset. We don't need reset, but it can be reset. Okay. So say it's gonna be a strut. Which will need to be reset, and will need to be pulled. Okay. Oh. Well, let's see. Interact with the messages as that index. That's that index. That's that index. Okay. Messages. Clear it. Okay, cool. So that should do that, and then game strut. type. Okay. We don't need to reset for that. And then we have variable. Okay, it's literally just this. The inode variable. Any target equals that target in target nil target is interrupt that inode. Node is that variable. That's that value. Okay. Let's see. Target. Cool. All right, so that's the general idea. So now we can say like this instead. Yeah. And that, there we go. Two field variables. Okay, so speed. This is on position. Okay, and then we say weight times 2. Set variable. So I mean, we can make this a little more comfortable. We can say, I mean, I guess we could make a function to do this, do some of this stuff. Well, no, because if you make a function, then you can't provide a optional argument. So. Well, I guess we could do like this: type set base movement, and then just set variable, just embed it, and then just make it so that do like that. So set movement is just set variable, but a little bit shorter, so you don't have to provide. Oh, you would have to do set variable. And then, yeah, no, that's not gonna work. That's definitely not gonna work. I mean, we could do, let's see, we could do it like this. Then yeah, I guess that's good, because then we can say, like, it's supposed to be a vector 3. Spacing can be the same. items. Stop. Too few. Really? That's interesting. So if you can't set target, right? No. Yeah, you can't refer to an unexported field. So that's, I never noticed that. That's interesting. You have to provide it by name if you have an unexported field. That's a little weird. Let's see. I'm just looking through this. This is quite an interesting case. AKA, it's kind of stupid to me because it's like, if you have an unexported field, then you can no longer define a struct using just the order of the arguments, but you couldn't possibly use the field. Like you can't specify an unexported field, and yet you can't refer to the exported fields in their order. Like you can't say, okay, well, it's min time and max time, and there is no target because target doesn't exist. Essentially, I can't touch it because I'm from outside the package. It doesn't work. It doesn't like that. That's weird and stupid. But I mean, it kind of makes sense. But it's like, come on, man. Like, well, I guess what you could do, we could do something like this. I guess you could do that, and then you could just say, like, oh, really? You can't do that either because it doesn't work that way. What? Let's see. Can you do that? Does that work? I feel like I've seen this before, but no. It's because it's a pointer method. Does this work? Okay, so that does work. That does not work. I guess you would do it like that. Yeah. So can I get away with not making a pointer? Let me see. Because that would be a little bit more comfortable. Well, this modifies the original, so that I shouldn't need to use pointers, right? Let's see. I don't think I do. Let's see. Oh no, because it's an action, it needs to be pointers to fulfill the interface. Yeah. So you can't use just an ordinary. Yeah, it doesn't implement the function unless. So you can, but now poll doesn't. It can never write to the struct. Which isn't a huge deal, but it is a problem here. Okay. So can we make a function like this? That instead of doing this, we can do this. Can I use? Let's see. Yes, you can. Okay, so you can do that. Action assembly. So I guess this is what we're gonna do. I mean, I kind of prefer this syntax, even though I don't like the ampersand. Not a fan of either approach particularly. I like the optionality of this. So I mean, I guess that's what we're gonna do. This is fine. But now we can't use any functions. Yeah, that does kind of work. It's not bad. I mean, we could do something like actions.new move randomly around area. It's a function. It has no arguments. And then you can say dot with options and provide a struct that is move randomly around area. Like this struct basically to define the parameters, and then you can obviously have it be optional. That's an idea. I guess you could do it like that. Provide an options, which could be, you know, like move randomly around area options, like that. Or it could be nil. Well, I guess it would be like that. So that it could be nil, and then you could provide a function like dot speed 0.02 dot Because that, I mean, that basically does the same thing. I mean, I guess you don't have to do it like this, right? You could just remove that. Which one of these two do I prefer? The function chaining approach is the same in terms of allowing the user to specify optional arguments. The reason why I like being able to specify optional arguments is that you don't have to, for example, set a target, because we can say the target is inferred to be the current object. So we want to be able to omit things as necessary. Around area. I guess if you do this, it's the same as this, but the thing is, like, I'm not a huge fan of actions.wait. Like, you provide a time and it's the minimum amount of time. I kind of wish it was just time if it was just one of them. So that could be a function instead. I also don't know how I feel about having to make pointers all the time. Like, it's not a big deal, but it is kind of annoying. Like, this would be better as a function, because then instead of it like being like this, we could just say actions.say and then just hi like that. That's a much better design, much more smooth. So I think it's got to be a function approach. It's got to be functional. So basically, it would have to be something like this. So this is the general idea. So instead of like this, it becomes that. I don't like either of these particularly because they both do good things at different times. I don't want to have, well, I mean, I guess I prefer this. Okay, so we could do something like this. And then this allows us to do this per se. So we just say. And some messages. String, messages. There we go. Cool. So that's a lot better. Pull. Okay. So set game locked. Just set game locked. There we go, that's better. So I guess this is actually a better approach because this allows us to kind of like make some arguments mandatory. Like if you're setting the game to be locked, you need to specify whether it's locked or not, because it doesn't make sense to do otherwise. Okay, set movement. Target. Because there could be, you might want these to be both null. Okay. Nil, rather. That is. Cool. I guess the target could be null, huh? Nil. Would you want to send it to yourself? Maybe. Cool. So I think we're good. Hmm. Oh, wait, rather. There we go. Alright, and then that's it for this. Then we just do it again over here. So we're locking and unlocking the game. We are stopping movement. We're saying hi. Oh, that's it. Okay. Hole. Okay, cool. Alright, so let's see how this works. Why can't I move? It's because... That's why. Whoa, he's going crazy. I forgot that I have to reinitialize the stuff. So here we can do all right, so then we just say the current action dot set. Okay, and then we just do the same thing over here. Okay, so pull. All right, so then if you can reset it, reset. There we go. No. What is? It's oh, hold on. Oh. Wait, is it just calling this? No, okay. Uh, okay, yeah. There we go. Cool. I mean, I guess I could just make it so that they all inherit from a base action struct. So pull and reset are both basically just undefined functions, and then they just overwrite those functions. That also works, because then I don't have to check to see if it's resettable or not. I can just call reset regardless of what it is, what it does. Either of those would work. I could just do like that and then pull. You could do something like that. So then this just inherits that. But now we can't. It would have to be in any. These couldn't be actions because there's no such thing as an action. Well, I guess an action would be this type. Action interface. Like that. And we'll just say it's pull and reset. Reset. Oops. That's an idea. So we could do it like that. Now we don't have to check to see if it's resettable or not. We can just call reset because it's going to be something. Now that makes every action a little bit more wordy because they all have to inherit from the base action. Even if the pointer is not specified, we still have to type that, which is unnecessary. Okay. Let's do it right. Cool. So it is working. So now we just need to set a state. Okay, so this would be another thing, set facing. All right. Too many arguments to stay. There we go. Okay, so then we could also say like change the state, change the target. Okay. So poll could be also unexported so that we don't have to worry about like it's not for people to mess around with. Same thing for reset. Oh no, we have to be able to access it from outside. I see. Yeah, there's no way around that, is there? I don't think so. Okay. I guess we could. Yeah, it's fine. We'll leave it like this. Let's not get too fancy. Oh, in the air. Cool. Let's see if we set the state. I see. So we really only want to do this. Okay, so I guess what we're gonna do like this. Next, polls. Okay, so that's the return int. So we would just say int that turn next. Next. Okay, so the reason why what I did just now, poll was a function that basically indicated whether the action was completed or not. So for example, if it was a wait action, then it would just idle until it was complete, at which point it would move forward and say poll next. Or rather, the poll function would return true. But now with switching states, you can't do that, because if you increment, like when you switch the state, well, active state should still be the original, right? Oh, but it wasn't calling reset. No, but wait. Yeah, hold on. Let's go back to the way this was. Set state game state idle. We call poll. Okay. Okay, we can do like this. Is that if it this is interesting. what I'm envisioning, the issue that I'm having here is if we look at this schedule, and when the NPC is idle, he's wandering, he waits, he stops, he waits, and then he wanders. So he starts wandering. So he starts wandering, he waits, stops, waits, starts wandering. That's the loop. If we interact with them, this loop stops and this loop starts, where basically wait. I have a library for this. I'm hold on. Yeah, I have a library for this. I can use the library. Let's try that. Let's try that. Yeah, let's try doing that. Okay, so let's go back. So this works. It works. There's nothing wrong with this approach. But we can use the library for this. So we're going to back up this entire thing basically. We can get rid of NPC state, get rid of states, maybe that as well. We can get rid of this, we can get rid of these. Might be able to get rid of these. Should be able to get rid of these. Should be able to get rid of... We're gonna do that some other way. Okay, cool. So, and this. Okay, so NPC just stopped. Okay, so what we can do is we should be able to just say something like this. We will need to grab it. We can go to this assets, scripts, source game. I guess build it. There we go. Did I add actions? Yeah, actions. New Okay, so this might be even better than before, because we can just say move randomly is a function. Well, it's not a function. It's actions dot new function. How do I? Okay, so you can do it that way. Let me see. I'm trying to. This could work really well. I'm trying to figure out like how exactly I want to do this. Let's see. I'll customize my little function. Oh, I'm sorry. Hold on. All right, I'm back. So, yeah, this is why I made this entire thing in the first place, dude. I made this framework, brother. I made this an eon ago, an age and an epoch ago. I grow weary. Okay, so yeah, this should work. We can do it this way. So we basically define a new function that just moves randomly. It works because we have closures. We can just point directly to the field. Easy. So and we can just reuse that same function. So move randomly. It is going to return flow next. We can say move randomly. We can do this. But you can't provide an argument to the function. Did I not try that? I guess I didn't. Let's see. Gate, collection, label jump. Well, I could definitely tweak it so that it just takes arguments in addition to the block. Well, no, because you don't call the function. The function is called. So how do we provide arguments? Oh, well, you could just make a function that returns a function action. Of course, yeah, that makes sense. So we can just do like this. Like if we wanted the speed to be customizable, we could just make it a function like this, and we return an action like that. Right? So the new function returns a function type. So we could say is the action is that function like that. So now we can say like, oh, we want the speed as an example. There we go. So now we can just say, give us this and give us a speed of 0.025 and what was I thinking on this one? Set X, Y, Z. I mean, should it return the thing? Probably not, right? Well, I guess it could return a copy of it, huh? Well, if you're saying the XYZ, it should take effect on the thing, right? You're not gonna probably. That was the whole point. You're setting it. It's XYZ. It can return a copy. I guess that's fine. Set XY. Well, now it's because XY doing this makes a copy of all of these, which makes sense because you're copying individual arguments, right? You have a 3-dimensional vector. You say set X, you're setting the X, but the Y and Z are unaltered. So you can make a copy of it and use it elsewhere. Set X, Y, Z, you're setting all of the properties. Okay, I guess this is fine the way it is. I guess that's fine. This is fine. I guess we could just do this. Well, we can just do it. Well, that's the same. Should be the same as just doing this, right? No, because it's making a copy. Okay. All right. Anyway, that's interesting. I'm not sure quite how to like reconcile those two concepts. Okay, so stop movement, move randomly, stop movement. Okay, cool. So this is this setup. And we should be able to then just say like in.routine.set run rather state idle. Oops. This will not work though because we do not have access to routine in here. So that means that we have to import routine, which we can do a couple of different ways. But we're going to do this the slow-ish way, which is to go here. And so we also want that. And then we run extract. I'm going to comment these out, though. Oh, I have to get it myself. There we go. There we go. Now we can do that. So routine is here, and now it is able to be used. Okay, cool. So now we should be able to go back here. We should be able to run it. Routine should be able to be imported. Oh, we have to import the actions separately. That's right. Let's go back over here. Can I just do, hold on, let me try something real quick. I want to see, can I just do like this? Does it know that? No? Okay. Alright, so that should work, I believe. Okay. Oops. Oh, do I have to make it loop manually? I guess I do, huh? Did I always, is that true? Like, is that correct? Oh, okay. Blocks will automatically stop at the end of their action list. If no blocks are running, the routine will also by default stop. Okay. Okay. All right. I'm not sure how I feel about that. I remember going back and forth about this in my mind, being like, a routine should loop once it's done, or a routine should stop once it's done. They're both kind of like not perfect in all situations, of course. Like if you have like an interaction, thing, you might define the interaction state and basically be like, okay, if I interact with it, start the interaction state, run through the interaction, system, and then end. I don't need to loop. But in this case, you would want this kind of like idle thing to loop. But yeah, it was just one of those things. Anyway, okay, so this guy's doing his thing. He's chilling. Okay, so when we get the interaction go ahead, then we can just say routine dot let me see, was there some way to start a block only? I don't think so. You just stop, yeah, and then run. Should probably say start instead of run. start and stop rather than run and stop. Buddy, I think I'm gonna make some changes to this API. Let's see. Oh, I did make changes to this. Okay, well we're still gonna make some changes. So this is now is running, which is better. Let's see. But is running only is basically if it's only running a specific thing. Okay, let's see. Let's see type part of this. I don't know. I don't remember even making these changes, but they are changes that I would have made, so. Okay. Yeah, so what I was going to do here now is change run to start. Yeah, that's what we're gonna do. Which means we can go over here and we're just going to go to Go Mod and replace that with this, that, which means this, or rather this. No, it's like, ew, what are you doing? Cool. All right. All right, so then we can close this, go back to symbols. Go back to symbols, go back to symbols. Re-extract just those two. I wonder if I guess I could make different shell scripts for different things, like, so I don't have to extract everything at once. So I can be like, oh, I only need to extract Tetra 3D, or I only need to, like, if I make changes to them, that probably would be better. That's true, actually. That's not a bad idea. Okay. In any case, we extracted the symbols, so now this should be using the correct API. Start, yes, okay. Start, stop. Oh, I see. So we're stopping everything and then starting. Yes, 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 okay. So we define this, so then we can say, whoops. Stop movement. Lock game. Unlock game. Like that, so... I guess we can just do it like this. Okay, so stop movement, lock game, unlock game. Then we can just say low idle. Alright, so that should work. Then we can say hi. So that's basically it. Undefined selector start. Oh, this is... Oh, this is an old... Oh, wait, hold on. Oh, my bad. It's routine. There we go. I don't think we need to do that. Okay, so let's try this again. Oh, well, I guess that's fine. I mean, well, it's, yeah. Well, I guess it's, yeah, we can deal with that. That's fine. Okay. So, what we'll do, we will make different shell scripts for this. This will be routine. Cool. Let's try this again. I think that's all that we need to do. Cool. Okay, so it does work. Oh, yeah, and when you're done, you can, block. Stop, set index, finish, run. To start. No, it just turns it to be active. Okay. Pause. New pause block. New. The issue that I'm having here is not really a problem. It's just something I'm observing. Is you go to interact with this guy, and he immediately walks away because it's restarting that idle block. This. Really, I want it to pause. Can I? Then maybe I just need to make it pause. Let's see. There we go. No, it's doing something else. Pause is pausing, but once you new run block, does it restart? No, because it doesn't start here. But I'm not sure. It's like it's not working quite right. Well, let's not worry about it too much right now. It's working. That's the most important thing. Okay, so let's see if we can kind of like restore some of this stuff. Now, we can't move this stuff to another package, unfortunately, because some of it relies on the NPC existing, right? Like setting the movement, which we could do correctly now. Like this. I'm wondering if I could set setting the movement wouldn't be a problem. I'm wondering if I guess I can move these to be on the struct, so it would be in.move randomly from home area. That's a function. That kind of works. For now, let's keep going. I don't know, like say you get something like that. Okay, so this does work. Let's see. So if that works, true. Okay. Let's see. Let's see. How do we do this? An if statement. Oh, so here we run it. Here's a function that returns a function. This is where a gate comes in, huh? Like, this is more elegant, but looking at it, you know, obviously objectively, like, you can't do multiple functions like this, right? Well, I guess you just would have to make the last function be the one that like is the expecting function, the waiting function. Oh, sorry. Whoops. Yeah, it's a little. I kind of like this system actually. I guess you could do it like that. Which is not too much worse. But the issue here is that I don't think this will work. Yeah, I don't think this will work. It does work, okay. Oh, wait. Okay, I guess interrupt that action consume. Right. There we go. I guess this does work. Well, can I make it so it's just a function? I think not, because you need an initialized function, right? Or no, I guess it could just be a function. Why is... Because, I mean, the initialization function is... It could be defined in the function itself, right? like say returning an action to that function. Like this is the initialization function essentially here. This could be a function and this could be called here. Or it could be called inside of here. So what if there was no init function? What if it was just... I mean, is it just it's got to have an init function and a poll function. I guess it makes sense. Let me go back here. Do I need to initialize here? Or could it be a function? Because I probably could make do with just functions of functions. And the upside of that would be... No, I guess not. That's what this is kind of what I was doing before. This will be combined. Just cause profile. Well, if it was a field, then it could be overridden now. Well, yeah, it would just be the same. I mean, it could be Yeah, actually, this would be... Let me think about this, because I'm wondering if it's possible, like, if I wanted, let's say, for you to be able to have multiple messages in this system, like, let's say something like this. Like, this won't work. Oh, actually, this won't work. Let's talk out. Yeah. I see. Right. For some reason, I feel like it's possible to do this in such a way where an action is just a function. The idea of that is really attractive to me. I'm just not sure how I would make it work. It would have to involve closures for resetting things. Like, if you have a function that is something like, let's say it's a timer, right? Wait. And it just returns a Boolean. Let's just say. So basically, target is time.now plus wait time. Wait time is given. Let's say it's duration, right? Time.duration. And then just says return time.after target. Now this won't work because in order for this to basically like be now plus some time, there needs to be memory, which means that this needs to be a closure, which means that this needs to be a function that returns a bool. In which case it could be like this. Like that, which also works. So now this becomes an initialization function, essentially. This becomes the update function. Now that I think about it, oh, right. I was like, how did I make this work? So I guess the idea is that once it basically, it would be like this rather. Like, the appeal of this is that it is just a function, or it is a function that returns a function. And so the upside is that no, I guess that wouldn't happen. That wouldn't work otherwise anyway. I guess that's what the gate system was for. Like, this worked because it's just a function that basically loops through and selects one of these actions to execute. but it is itself a function that returns a function that sets this stuff. So like the message index is equal to 0. This works when there's one message, but when there's multiple messages, it doesn't work. So yeah. So I guess what we could do is do something like this. Okay, this is gonna have to be it, because I'm running out of time. Dude, it's something like that. it's something like that, brother. I think I need to do that, and then I guess that doesn't need to be there, and then like that's something, dude. I don't know. So something like this should work, so we don't have to do this kind of weird thing. We can do this. This becomes a little bit more doable. I mean, really, I guess what we could do, we could kind of combine these, right? Where instead of it if being a function that's bool, it just returns a slice of messages. right? So that kind of does the same thing. Conditional say option. Now we have this, where we basically say if talk count is equal to 1. Well then, yeah, can't we just use this? This is a weird thing. Because if that's the case, then we don't need the conditional say option at all. We can just provide a function that returns a slice of strings. Let's see. Oh, I see. It's because O is a conditional say. It needs to be a pointer. Conditional say option needs to be a pointer like that. Okay, that works. So that means that we can just do this. Messages. Index. Plus. Index 0. Okay, so let's try that. $208. Oh, oops. Yeah, down here. Okay, so then we just provide this. There we go. Okay, so yeah. Cool. Okay, so that does work. So we can do a conditional say that basically runs a function and then returns the things to say. Well then, doesn't that mean we could just make say be a function like this? So it runs the function to see what strings to pass. These are the same thing then. You can just say. Yeah, it's the same thing. So that means that this could just be really a conditional say but the function just returns the text strings. Buddy, we're cooking. Okay, so we can do some crazy stuff with this. This is a little weird, it's a little wonky, but it does work, and you do have like control. It's not like you don't have control. Ugh. All right, well, I gotta go. But yeah, thank you very much for watching. I've been Solar Moon. This has been real. It's been fun. It's been weird, and I'll keep working on this weird like definition of this like action system and all this stuff. It's always interesting and fun to work on. Anyway, thanks for watching. I'll be on next time on Wednesday. All right, see ya. Bye.